Right, so I'm going to look at two processes now which produces ethanol, and I'm going to compare the sustainability of each of the process so that we can have a look at which process is more sustainable and which one is less. So the first reaction is fermentation. Now fermentation is a process that produces ethanol, and it is a process where you take glucose and you react it with in the presence of yeast, which acts as a catalyst, and you get ethanol and carbon dioxide. So that's one process that produces ethanol. And then the other process is the hydration. So remember, hydration is to do with water, of ethene. Ethene is a hydrocarbon. It is unsaturated. It's got a carbon-carbon double bond. It is made from cracking, or can be made from cracking. And what you can do is you can take that ethene and you can make ethanol. Now, this process of making ethanol is in the presence of steam, and it's more of a process which produces ethanol that we use for sanitizing, whereas this process is ethanol that you use to consume. So this is more consumption-based ethanol, and this is more chemical-based ethanol, where you are using to sanitize it or put it into other substances. Now, in terms of sustainability, you've got to think about which reaction is more sustainable and why. Now, if you look at ethanol, ethanol comes from glucose. Glucose is obviously sugar. Sugar comes from plants, so that is sustainable because that is something that can be planted. You can get plants and replant them. Ethene comes from crude oil. Crude oil is finite, it will eventually run out, so that is less sustainable. Fermentation is more sustainable. Some of the disadvantages, I guess, is ethanol is made in fermentation, but there is a byproduct, so that needs to be separated. So there's a requirement of separating this carbon dioxide, whereas in this case you've got 100% atom economy, which means there is no other byproduct, so there is no separation required, which usually takes time and money. Secondly, this reaction can generally happen at around 40 degrees Celsius because yeast is a biological catalyst, and if you increase the temperature beyond 40 degrees, you're going to end up denaturing it, whereas this process can happen at a high temperature, and therefore it is the reaction will happen much more quickly. Also, in terms of the process, this is known as a batch process, which is a process that is made on demand, and this is a continuous process, which is basically a process that is always happening because of the requirement of ethanol. So what you're doing here is you're looking at sustainability. That's the key word here. Which reaction is more sustainable than the other, and then also comparing advantages and disadvantages, and they both have each of them, and you need to be looking at that. I'm going to quickly look at a couple of other functional groups that are a bit difficult. Often students struggle with this, triple science students, looking at carboxylic acid. So carboxylic acid is a functional group that has a C double bond OH next to it. Remember, when you draw the display formula, you've got to make sure that you show all your bonds. This is something called ethanoic acid, often found in vinegar. It's a weak acid because the acid partially dissociates. So ethanoic acid, you can then react this with an alcohol, say ethanol, and you'll end up making a new functional group called ester. Now the way you'd want to draw this is quite important. So you draw your ethanoic acid here, and what you need to do is you need to make sure that the ethanol, which is a functional group that has an OH on it that's facing the carboxylic acid group. So what you can then do is take out H2O. So if H2O is taken out, you get a product from that. So your product will be, your CH3 stays exactly the same as it is on this side, so this is there. This C double bond O stays where it is. This is that, and then you've got a part of the alcohol group which is there, and then obviously you've got plus H2O which was given off. So that's basically an esterification process where you take an carboxylic acid, you take an alcohol, make sure the functional groups are facing each other, and then you'll end up with an ester. To name this ester, you name the alcohol group part first, so that's ethyl, so ethyl, and then ethanoate, which is a name of the functional group ester. They usually have a really fruity smell, so they're often used in perfumes, so that's one of the ways of distinguishing whether you've made an ester or not.